Good afternoon, ladies and gentlemen. Thank you very much for joining us for one of the last sessions of the day. If I may say so, I think the conference organizers have saved one of the best sessions for you for last. Hydrogen has been a particular hot topic at this conference, but of course for the last few years in the news as well. Before I introduce my panelists, if I may just set the stage for you, if you look at the level of investments in the clean hydrogen sector, we've seen significant growth over the last few years. For 2023, we tracked over $34 billion US worth of investment, and that accounts for about more than doubling of investment relative to 2022, to be exact, a growth of 134%. And we've seen growth across all regions. Europe's still leading, but we have also seen significant growth here in Asia Pacific, and actually India has been a very hot market, particularly with the new auction scheme. And we are very lucky to have some of the players that are involved in developing projects here. So without ado, I'm going to start off by introducing my panelists, as well as asking them to briefly tell you about the work that they're doing related to the clean hydrogen. I'm going to start right to my left with Phil, with Ceres Power, a very innovative company producing solid oxide fuel cells and now expanding into electrolyzers. Phil, if I may ask you to briefly explain what your company does in the clean hydrogen sector, please.
Yeah, sure. Hi, everybody. So I'm Chief Executive of Ceres Power. We're a British technology company, and we develop very high efficiency solid oxide technology. We're very interested in industrial decarbonisation, where when you can integrate these technologies into things like ammonia, green steel, synthetic fuels, you get a 25% efficiency advantage. And that's huge in terms of a much lower cost of ammonia, potentially, or potentially about 20% more production from your assets. And because we're a licensing business, we enable people to make this technology locally. So we're very much open to look for partners in India, given what's going on here. We already have a track record with partnerships with Bosch in Germany, Doosan in South Korea, Delta in Taiwan, and Weichai in China. So that's Ceres.
Thank you very much, Phil. Ashwani, if I may bring you in, ACME, I think many in the audience may be familiar with what your company is doing, and congratulations on the recent MOU with IHI. If you could please explain around what your company is doing in this space, please.
Thanks, Ali, and thanks to the organizers, especially the Ministry of Petroleum and Natural Gas, to have put up a beautiful show here. This is for the first time I'm attending this. Let me just start with a small introduction of ACME. We are, like many other renewable power companies, not a very old organization, just about 2 decades old. But in the last 2 decades, we have a history of creating disruption in various markets, where we worked initially in telecom sector, then in the power sector, and now in the ammonia sector. We were the first one in the world to have built the fully integrated green ammonia project in Bikaner. It's a small 5 tons per day project, which is now running for more than 3 years in continuous operation, and we are loading 1 truck of ammonia every 10 to 12 days from there. And based on the learning and experience which we have gained in this plant, we are developing several large-scale, utility-scale projects in Oman, in India, and in United States. And as Ali said, we have been fairly successful in converting some of the leads into real business opportunities. We were the first one in the world to have signed a non-affiliated arm's length contract with Yara back in 2023. And week before last, we signed another deal with IHI of Japan. And we are hoping that this string will continue and we will be able to build more and more projects.
Thank you very much, Ashwani. Ranjit, if I may bring you in, Ocior Energy, again, I'm sure many in the audience would be familiar, but just in case, if you could please explain what your company does in this space, please.
Thank you, Ali. I represent Ocior Energy, and we are Ocior develops, builds, owns, and operates green hydrogen, green ammonia projects. We have several MOUs across the states in India with Egypt, with Jordan, and we are trying to develop a project in Abu Dhabi also. Our two flagship projects are the project in Egypt, which we are developing at the Ain Sokhna SE zone. It's a 1 million tons per annum project, and we are working on phase 1 of the project currently. The other project that we are working on is the project in Orissa, which is a state on the eastern coast of India. And that project too is a 1 million tons per annum project, which is going to be done in 2 phases. And we're working on the phase 1 of that project at the moment. Both these projects, which were envisaged by Ocior, are for the export market. The project in Egypt is envisaged to export green hydrogen, green ammonia to the EU market, whereas the project that we are envisaging on the east coast of India in the state of Odisha is expected to market its product in the East Asia markets like Singapore, Japan and Korea. So that is what is keeping us busy. Thank you.
Thank you very much. Dr. Prasanna, I think ExxonMobil doesn't require an introduction. Could you please tell us a little bit how Exxon is looking at the hydrogen space?
Yeah. So first of all, glad to be here. ExxonMobil, as you mentioned, we are in the energy and products industry, so we are a major oil and gas player globally. One of the things on energy transition we are doing in our existing businesses is first to reduce our own emissions in our existing operations. That's one of the focus areas. We formed a low carbon solutions business about 2 years ago, and the focus for that low carbon solutions is in 3 major areas: carbon capture, utilization and storage, hydrogen, and I'll come to the hydrogen in just a minute, and biofuels. So that's those are the 3 focus areas. Speaking of hydrogen, I will say hydrogen, we are color agnostic. However, we look at hydrogen from 3 different dimensions. Is it scalable? Is it affordable? And is it reliable from a security perspective? So our focus currently on hydrogen, given those 3 dimensions, is blue hydrogen to begin with, because majority of the hydrogen produced today is gray, and you can put a carbon capture, storage or utilization and storage facility at the back end to make it low emission or clean. So that's where we are starting. However, we are open to all colors and will evaluate the value chain as technology progresses. Looking forward to the discussion.
Thank you very much. Paddy, Zero Petroleum, very evocative name. Could you please tell us a little bit about what your company does?
Thank you. Firstly, great to be here in India. It's my first panel in India, so thank you for the welcome. Zero Petroleum, yeah, the clue in the name is zero fossil carbon in effect. So we're making synthetic fuels, we call them synthetic. You may have heard also of power to liquids or e-fuels, electrofuels. These are all a category of fuels made from green hydrogen is the core energy component of these fuels. And then what we do is bring in the carbon from either a biogenic source or from direct air capture, and this turns the hydrogen into the hydrocarbons that we know very well as diesel or jet or gasoline. So we turn the green hydrogen into effectively a very practical substance for mobility and for logistics and storage.
If I may ask you a follow-on question, Paddy. So these green hydrocarbons that you're producing by taking green hydrogen and then making the e-fuel, what applications are you targeting first? What do you see as the most promising application in the short term?
So yeah, the great benefit of a liquid fuel, so liquid synthetic fuel over straightforward green hydrogen, is around energy density and the practicality and the safety of the use of those fluids rather than the gas. And so the primary target will be mobility, but that's not just transport, that can include agriculture or mining, many other heavy industries, not just the mobility itself. Obviously within mobility, aviation is a very big subject and one that gets a lot of attention. So jet fuel will be the very first on the list, but we also have a very strong product in gasoline. So actually one of our specialities at Zero Petroleum is gasoline as well as jet, or sometimes what you hear SAF, sustainable aviation fuel, but this would be an eSAF, so electrofuel SAF.
And if I may ask you a follow on that, so for these applications, what is the challenge to scaling it up? Is it just a cost difference, or do you need specific subsidies, specific policies?
Well, the very exciting thing about synthetic fuels of this type is that they are a pure technology play. The feedstocks are literally air and water. So the water to make the green hydrogen and the air for the carbon. So feedstocks are in effect free. It's a pure technology to convert that into a liquid fuel, all the way from the generation of electricity through the electrolysis and through the synthesis. So the cost will keep coming down. In fact, we predict from our own modeling to achieve cost parity with current crude prices within 10 years. And that's simply because it has a cost down formula, as we've seen in all history in industry. You know, constant development will bring costs down.
Thank you very much. Phil, if I may bring you in, so Paddy alluded to specific applications on the liquid synthetic fuel side. So you're making fuel cells as well as electrolyzers. What are the applications you're prioritizing in the short term?
Yeah, so look, I've been in fuel cells and hydrogen for 20 years. And at one point I was working on fuel cells for automotive. With Ceres, we focus very much on commercial scale stationary, where we're more efficient than combined cycle gas turbines. And then on the hydrogen side, you know, what I've realized over the years is at one point hydrogen was considered to be the solution to many, many problems. And if you look at the Hydrogen Council, they're saying hydrogen could be 18% of primary energy by 2050. Actually, I'm not convinced that's going to be the case, but where I am absolutely convinced is if you just look at industrial decarbonization, which is about at least 20% of carbon of global emissions, we cannot get to net zero unless we decarbonize grey hydrogen in some of these industrial processes, like ammonia for fertilizers, like our steel industry, like our cement industry, like our fuels. And that is really at Ceres where we focus on the hydrogen side. So we're focused very much on industrial decarbonization, which is a huge market. It also plays to our strengths because with heat integration, we have a huge efficiency gain of about 20-25%, as I mentioned. And then on the stationary power side, we're fuel agnostic, so we can use natural gas, we can use blends of natural gas and hydrogen, and we can use pure hydrogen. And that's also about distributed power generation as well. So they're the key markets for us. And
within the existing applications of hydrogen, so roughly, if I recall correctly, that market is about 100 million tons annually. And then if you look at the new applications, depending on which scenario you pick, you can have significant demand from the steel sector, from looking at aviation decarbonization. Between that split of existing versus the new potential, which ones are you prioritizing?
So if you look at the demand for potentially green hydrogen, if we're going to hit the targets like we mentioned in the Hydrogen Council, you're going to need something like 3,000 gigawatts by 2050 or 300 gigawatts a year. And even India's got very ambitious targets, 5 million tons by 2030. That's about 100 gigawatts. Today, you know, we're in the low gigawatts. So for me, this is a massive, huge, massive market opportunity that's unserved. And for Ceres, that's going to require new entrants. That's going to require scale. And that's where our business model comes in. So our partnerships with like Bosch and Doosan, we provide the technology and they really provide the mass manufacture. Because if we're going to really hit these targets, technologies like solid oxide have to scale and scale rapidly. So we're very much targeting on these high growth markets.
Thank you very much. Ashwani, if I may bring you in, so you have a project in Oman, very soon commissioned, and then another one that you just signed an MOU. What applications are you prioritizing for the output of your green hydrogen and green ammonia?
Of course, the low-hanging fruit is the existing fertilizer and chemical sector, and everybody is going after them. That's an easiest market one can capture, converting them from gray to green. But we are investing a lot of time and energy in developing other applications. For instance, IHI has a technology where you can monofire ammonia in a turbine, and it works like a gas turbine to generate power. And that has a number of places where you can, use them. That, for example, islands where you can't have the large solar power generation or wind power generation, let's say Andaman and Nicobar or Singapore, and what you save is the backcracking cost and energy, because these countries can't produce their own fuel. If they import from some other country and backcrack it, they lose energy. So there is a lot happening on the technology side, on power generation, in heating applications in the industry. And one sector which is very promising for ammonia is the maritime sector. So that's something which, again, we are working very, very closely with the like-minded organizations. We are part of a number of ammonia energy association, clean fuel ammonia association. We are jointly targeting to influence some of the upcoming policy regulations and guidelines by institutes like International Maritime Organization. So we are targeting all sort of applications, but of course, the early success is likely to come from the low-hanging fruits rather than the tough ones.
If I may ask you a follow-on question specifically on the India market, how do you see the market developing? Do you see domestic demand driving offtake, or do you think for the foreseeable future it's going to be primarily export opportunities?
So actually, India has done a beautiful job of creating this national green hydrogen mission, where they are not just incentivizing production like the way US has done in way of IRA, but they are also incentivizing consumption. There is a national green steel policy, there is a national green port policy, there is a tender which is out now for buying. There was a tender, first of all, previously for awarding tax subsidies on production. Now there is another tender which is very soon going to come on purchase of ammonia and hydrogen. There is also a move to mandate refining and city gas distribution for blending. So a lot is happening in India, and I think India is actually setting a right model by not just emphasizing only on one part, which is production, but also incentivizing consumption. I would personally, if I have to make any suggestion to the other governments across the world, I would say that particularly US should also focus on incentivizing consumption rather than only focusing on the production side.
Thank you very much. I would like to bring Ranjit into this discussion as well. Before I ask Ranjit the same question, I have one more question for you. So in the last round of the auctions here in India, there were some bids at zero, if I recall correctly. I was wondering if you have any thoughts around why somebody would bid zero to participate in the auction.
In India, there was a movie, some of the Indian people will understand, in two sequels, Bahubali 1 and Bahubali 2. And until Bahubali 2 was released, everyone was wondering that why did a person kill another person? And this question is something like that. I don't have the answer for it until it is revealed in maybe sequel.
Thank you very much. I'm sorry for putting you on the spot. To be fair, that question was, we hadn't discussed it before, so sorry to put you on the spot. Ranjit, if I may bring you into the same discussion, how do you see potential market opportunities? You have the project in Egypt. It seems like there's a lot more demand today in Europe. How do you see the evolution of demand here in India and the rest of APAC?
I think my comments are going to be similar to what Ashwani is saying, that when we started our journey at Ocior, we believed that the market was largely in EU, and that's the reason why we looked at building our first project in the MENA region, which is why we chose Egypt to develop our first project. There is a very ambitious plan that the EU has of importing 10 million tons of hydrogen by the end of this decade. And I understand that a lot of cracker plants are being built across the coast and on northern Europe side, where they plan to bring in ammonia and crack it back to hydrogen for industrial use. Apart from that, as you know, there is a lot of work going on to make ammonia as a marine fuel to replace furnace oil or fuel oil, which is being used in marine shipping industry currently, and use ammonia instead. So from that perspective, we had set up the project in Egypt. I feel that that thesis is still is very solid. EU is looking to buy hydrogen and ammonia. On the east side, over the last year and a half, we have seen with Japan, working on burning ammonia in their coal plants 20% and going up to 50%, and with this marine fuel hub in Singapore planning to continue its being a marine fuel hub and convert from furnace oil or fuel oil to ammonia. There is demand on the east side, which we will be targeting from our plant in Orissa. In India, there is a possibility that there will be a small tender that will come out, which will aggregate capacities. I think it will largely be from public sector undertakings. I believe that whether it is India, whether it is EU, whether it is Japan, in the first 5 or 10 years before parity between grey and green is achieved, we are looking at very small quantities coming into the market, maybe 4%, 5%, 7%, 10%. And unless and until everyone gets together and decides that it's okay to pay slightly higher numbers for 5% or 10%, which will eventually not affect the final user of the product, I believe that the world should move forward and encourage offtake of green hydrogen and green ammonia.
If I may ask you a follow-on on the technology side. So if I understand correctly, your current project pipeline is primarily using alkaline electrolyzers. We just heard from Phil about solid oxides potential. How do you see the technologies for production of green hydrogen and by extension green ammonia evolving?
So, at the moment, the way it looks like that the SOEC technology is far superior to PEM and to alkaline. The question is about the cost, and at this cost, which currently SOEC is at, it is more commercially viable for all of us to go for alkaline. However, I think the SOEC technology is progressing. The scale or the size of individual cell is also increasing, and we are hopeful that by the time we build our second phase of projects towards second half of this decade, we will all, as an industry, move to SOEC. I somehow feel that PEM is going to get the short end of the stick, and people will probably go from alkaline to SOEC directly.
Thank you very much. Dr. Prasanna, if I may bring you into this discussion. So at the beginning in your introduction, you mentioned that you're primarily focused around looking at blue hydrogen and turquoise hydrogen. Can you please explain a little bit more around why Exxon is prioritizing those over green hydrogen for now?
Yeah. So there are really 3 factors that we look at when deciding on what end-use sectors or production. First of all, hydrogen, as you rightly mentioned, it is an energy carrier. You need to have a production method and the end use. So the first part of the philosophy is deploy solutions that are available to be deployed at scale today toward furthering that energy transition, starting on it now. The second part of the philosophy is use existing infrastructure. There is so much of existing infrastructure in place. So use existing infrastructure to get started on the energy transition. And the third piece is policy enablement. It's an additional cost to produce low emission or clean hydrogen. Where is the policy that enables that production? So given those 3 philosophy principles, if you will, let me now go back on the demand side and just try to articulate our philosophy. So today we use hydrogen in our own operations as a feedstock for hydrotreating, for making methanol and other chemicals, as well as ammonia, not in our operations, but that's what is used. And as you rightly said, 100 MTA of demand is in existing. Based on what I said, first part is how can you make that low emissions? And that's where the carbon capture, utilization and storage comes into play, because that technology is available to be deployed now. So that's where blue hydrogen is a focus, because that can be low emission today. We have announced the largest blue hydrogen project in the world, 1 billion scuffs per day in our Baytown facility. and that's going to decarbonize our existing operations. The second application that I will mention that we are focusing on is fuel switching for industrial heat. We use a lot of natural gas today for heating or producing that industrial heat in steam cracking, boilers, process heaters, and so on and so forth in our operations. Instead of burning natural gas and capturing CO2 at the back end, you can actually make blue hydrogen in one single large facility, and instead of burning natural gas in distributed manner, burn hydrogen instead, because the CO2 from a blue hydrogen is much higher in concentration and much cheaper to capture. So fuel switching is the second application we are focusing on at the Baytown for our internal operations and third party. The third application which we will focus on in the later stage is, industrial, other industries, heavy industries, steel, for example, steel industry. And that's where some of the low carbon solutions, third party business building is focusing. Today, steel is manufactured using coal as a reducing agent. Hydrogen is the ultimate reducing agent that one can go to. So how can we place hydrogen in the steel manufacturing is the other focus. Now, couple focuses on the demand side that will come later in my view is power generation, mainly dispatchable power. And I will make this statement an assertion that green hydrogen for dispatchable power makes sense only when there is surplus electricity from the grid. And I will say that again, only makes sense when there is surplus electricity. If you are stealing electricity from the grid to make green hydrogen, that's the least efficient way to use electricity. So where it makes sense is you have sun shining, wind blowing, solar panels are there, it's generating electricity, but the demand is not quite there during the day. Hydrogen, green hydrogen makes sense. And that's where storage solutions, the challenges are you need storage solutions and efficient use of the hydrogen to make electricity back when it's needed, when sun is not shining and other pieces. The last application that I'll mention is mobility. Mobility is a future for hydrogen. However, hydrogen suffers or doesn't have the volumetric energy density that some of these long haul applications will require. Let's assume light duty vehicle get electrified. Hydrogen will have a role to play in long haul heavy duty operations or vehicles and short flights, not long haul aviation, but short flights because of that disadvantage of low volumetric energy density. So those are some of the applications which we are progressing near term, mainly focused on industrial, longer term looking into mobility as well as dispatchable energy.
Thank you very much. If I may pick up on the point that you mentioned about the challenges with volumetric energy density and ask a broader question. I think in the earlier discussion we already talked a little bit about ammonia, as well as I believe Ranjit also mentioned about Japan's plans for co-firing ammonia with coal. So the question I'm trying to get at is, today a lot of our energy when it comes to seaborne transport is easily carried by ships around when we look at coal, LNG, and oil. How do you see the seaborne transport of hydrogen? Obviously, there are different technology options there. If you can please share your thoughts around the competition between those technology options. And then, if I may add one additional point around it, do you, for example, see the same level of seaborne transport of energy to be able to replicate it with a vector like hydrogen if you're looking at, for example, the volume of energy that's right now transported using LNG?
Yeah. So this is where economics come into play. All options have to be compared on a delivered basis. Let's say you need delivered energy in Japan. Here are a few options. You can ship LNG to Japan and burn that natural gas, but it's not low emissions. Then you can make ammonia. Ammonia becomes a means to extend the value chain for hydrogen, either cheaply in the Gulf Coast of United States because gas is cheaper from a blue perspective, or Middle East, and ship ammonia, but then you have to crack ammonia back into hydrogen. what's that cost? And then you can ship hydrogen as liquid hydrogen. There are technologies that are being worked on, like KHI as an example. There are some pilot projects. All these technologies or all these options have an additional cost. And we talk about color. Once hydrogen is made, it doesn't care what color it is. Hydrogen is a hydrogen molecule. And it's just what's the cost of production is where the color matters. Once hydrogen is produced, all these three options are fair game. Now, ammonia supply chain is established today. Ammonia travels from a fertilizer industry perspective. So going back to one of the philosophies that I mentioned, use existing infrastructure as much as possible because that's the lowest cost option to get there. We believe ammonia will be the first one that industry will look at to extend the value of hydrogen value chain from a sea transport perspective. But then can you use ammonia as ammonia in some of the applications to be the lower cost option economically, or do you have to recrack it back to hydrogen is the question. So 100% ammonia burning, either in power generation or other means, is a technology that others are focusing on. So if we can figure out from a technology perspective, that becomes an immediate option. Other technologies, as I mentioned, liquid hydrogen will have to come down on cost and optionality because hydrogen is one of those molecules where thermodynamics is against you. You need minus really low temperatures to keep it liquid to transport.
Ashwani and Ranjit, I would assume you agree with ammonia being the early option, but if you may have any thoughts around seaborne transport of hydrogen and which vector you see the most beneficial. Who would like to go first?
I can take the
Sorry.
Should I say? Yeah. Okay. So, though I agree with what Prasanna is saying, but I always have this issue with the oil companies and oil and gas companies, right? Because they'll always shift the focus from green to blue or green to gray, right? And obviously, there is a cost to green, right? And definitely that cost to green is slightly higher than the cost to blue. But the fact is that, there is no need to transition from gray to blue to green. We do need to push harder on the green transition faster. We can't afford to go, stepwise currently. And, as far as the points that Prasanna has made about infrastructure and so on and so forth, those points are well taken. The point is right. But the fact is that, the infrastructure for green can easily be developed. And, there are applications of hydrogen which are touted, which simply do not make sense, and they actually, like he mentioned, right? I mean, burning hydrogen for producing electricity doesn't make sense. And when people push that, it just makes the whole argument of growing green weaker. So I think we as an industry for green need to also have our arguments in place where we need to demonstrate how green and gray parity can be achieved and what will be the cost curve to go from gray to green. If I put green hydrogen into, let us say, making green steel, and then a Rolls-Royce converts that green steel into a car, right? The cost of the final product is going to go up barely 1%, if anything, right? So, I mean, those kind of applications, either the market or the regulator or the customer or the company needs to embrace. And we have seen this in India, right? I mean, unless and until we take that step and go after getting solar, for example, India bought solar at 30 cents, 40 cents, and now we are buying it at 3 cents. Unless and until we go on that journey, it will not happen.
Thank you very much. Ashwani, your thoughts?
So I'd just like to add a couple of things. One is, of course, as Prasanna said, ammonia seems to be the most promising hydrogen carrier at the moment, and there are applications being developed, especially in the far eastern part of this world, where you can burn ammonia directly for a number of applications rather than backtracking and losing some energy. But there are other promising technologies like the organic compound, which can do, you can hydrogenate an organic compound from the loading location and dehydrogenate on the destination side. And some of the early results, it's not available on a very large commercial scale at the moment, but some of the early results are very promising, and it might actually be one of the options potentially available for carrying hydrogen in future. Liquid hydrogen, again, Prasanna mentioned about KHI, but the joke in ammonia industry is that, or the hydrogen industry is that what was loaded in Australia, not even half of it could reach Tokyo, and it was only a 10-day voyage, right? So there is no metallurgy available for minus 265 degrees Celsius at the moment. There is no storage capability which is existing today. LH2 is going to happen, but it will be a long time away. So that's as far as transportation is concerned, but I just want to bring one more interesting topic on green you mentioned. So I think it's the whole hydrogen sector is divided into two parts. I come from, out of 30 years, 28 years I have spent in Shell and BG, which is oil and gas. So there is one segment which is existing oil and gas players who are promoting the so-called blue as a transition towards green. And then there is another part which is, the power generation companies who see this as a natural downstream extension of converting green electrons to green molecules. And both of them have their own points of views. Some have merit, some are just for the sake of argument. And I think in the very realistic world, both of them are going to exist, and a lot of geopolitics is also going to come into picture. Shipping cost is a very important factor. If we have a project in India, East Coast, shipping to Japan is half the cost or less than half of the cost compared to shipping it from Gulf of Coast to Tokyo. So those are some of the factors which will also come into picture, whether it is blue or green. I think it is something which only time will tell. But one thing which everyone at least has a consensus on, that eventually green is the destination everyone wants to reach.
Thank you very much. Dr. Prasanna, please.
Yeah, if I can add, and I think these points are valid. I'm not suggesting that oil and gas is the only option. All solutions are going to be required, absolutely. But you have to progress all solutions and let the market decide. And ultimate question is, what's the cost to the society? And are we progressing on that energy transition? If there is a solution that is 95, 98% there, in my view, we should start progressing that versus waiting for a 100% solution 10 years from now. And all solutions are going to be important.
Very valid point. Paddy, if I may bring you into this discussion. So we did talk about different carriers, primarily ammonia, liquid hydrogen, and Ashwani also mentioned liquid organic chemicals, LOHC. We didn't actually mention synthetic fuels that much as the carrier option. Your thoughts on that?
Yeah, I mean, technically that is correct. That's in the organic range. And I think we've had some great input there from my colleagues on the panel. But, one of the great things about synthetic fuels, synthetic hydrocarbons, is that they absolutely use all the existing infrastructure. We call our fuels 100% drop-in, so they are using the same logistics, the same storage, the same transport, and then, crucially, the same vehicles. Not only in a legacy sense, but in the long term because of that energy density aspect. And I'd like to bring up a new thought around that, because we're talking about moving energy around the world. And, it's great to be here in India. India has such an incredible opportunity here with its resources around energy generation, wind, solar, etc. One of the characteristics of renewable energy generation, and by the way, that has to be the heart of everything we talk about in the transition, other than nuclear, is, if we're replacing oil that's come out of the ground, that energy, we have to replace it with renewable energy. You can't get away from that equation. India has that possibility to be a huge generator, but typically this energy is not generated anywhere near where it is required as electricity. And even if you convert it into hydrogen, yes, there may be other types of transport media, but ultimately the very best by a country mile is a hydrocarbon liquid. And moreover, it can be used directly then at the end of its journey in our existing vehicles and other applications. So we find that really exciting, and as I said earlier, because there's this cost down formula, a country like India can become a huge oil nation, but in the new world of synthetic oil.
If I may ask a follow-up clarification question. So for the synthetic fuels, obviously you need the green hydrogen, but you will also need the CO2, and so you would have to bring down the cost of the CCS side. So in a way, you're advocating, if I'm understanding correctly, that primarily the hydrogen would be green hydrogen, but the CO2 would be coming in from another facility where you're capturing the...
Well, in the model I described, the carbon will be coming from the atmosphere. Now, direct air capture is characterized at the moment as being impossibly expensive, very, very difficult, etc., etc. Firstly, it's a very new development, and there is huge opportunity to bring down the cost, improve the efficiency. And the other benefit it brings is that you have no reverse logistics. If you can generate the carbon from the atmosphere right on site where you're generating this super cheap electricity in uninhabitable areas of the world, particularly, India has already started that with vast solar farms. You bring the carbon in locally, it's again super cheap, will be much more efficient than today. You have no logistics whatsoever except to export a liquid fuel as we do today with fossil oil.
Thank you very much. Phil, if I may bring you back in around the question on the production side of hydrogen. Ranjit made a really interesting comment earlier that maybe we'll leapfrog from alkaline to solid oxide once the solid oxide technology costs have come down. To the extent that you can share with us your cost outlook, when do you see solid oxide becoming more competitive versus alkaline?
Yeah, look, I actually share Ranjit's view, which is I actually think that today, with the urgency of deployment in India, people are looking for existing technology. And I used to work in the chlor-alkali industry. It's a very mature technology, and it's down the cost curve. So alkali is the technology to beat. But it's not the most efficient. And I think efficiency always wins in energy. So the criticism that's always held out there with solid oxide is, oh, it's a really promising technology, but it's not mature yet, or it's too costly. And so to directly answer your question, we're already scaling up the technology. We've been doing scale up on the fuel cell, the power generation side for the past 10 years or so. We've now got 3 manufacturing partners globally already putting in hundreds of megawatts of production. That's Bosch, that's Doosan, that would be Delta, and we're talking to others now. So our technology, because it's steel-based and it's a lower temperature, doesn't use some of these expensive components. It doesn't use any precious metals. It doesn't use iridium. It uses steel and cerium, the most common of the ceramic materials. So basically, it just becomes a matter of scale. And we have to prove this technology out. We're very excited. We're going to be, I believe, the first solid oxide to be deployed in India. We're doing that with Shell in Bangalore later this year. So that's a first megawatt scale demonstrator here in India. That will prove what we say about the 25% efficiency gain. But then beyond that, we're also in parallel scaling. And this is important. You can't wait and do everything sequentially. Because the prize is so big in terms of the energy efficiency and the low cost that it unlocks, we do the manufacturing at scale in parallel with some of the technology. But we've been doing this for 20 years, so solid oxide is a lot more mature than people think. And there's a word of caution here. Everybody's grabbing, cheap alkali technology. You're trading quality and reliability and lifetime. So, there's a levelized cost of hydrogen includes lifetime, and we work very hard on that as well. So.
Thank you very much. For the remainder of the time that we have, I would like to focus around asking you about your recommendations to India specifically on the policy side. We're unfortunately having just about 8 minutes left. You've already a little bit mentioned different policies, for example, in the US with the Inflation Reduction Act and the tax incentives there, in Europe with carbon pricing, as well as the green industrial mandates, and then, of course, here with the auction mechanism and the potential the demand side mandates as well. Phil, if I may start with you, what would you recommend to policymakers here in India to consider in terms of fostering sustainable growth of the clean hydrogen economy?
Well, look, 2 or 3 years ago, I don't think India was even on our radar, and now it's suddenly become one of the most important markets, I think, for this technology. And I think India has an opportunity to leapfrog. If I look at what's happened in Europe with repower and what's happening in the US with the IRA bill, they seem to be slowing down because of bureaucracy. So I like the ambition here in India, but I think it's got to keep going and actually get to that deployment. I think the 5 million tons is hugely ambitious, but I think I like the sentiment. So as long as bureaucracy doesn't get in the way and these projects can actually get deployed, because what we've seen in Europe and elsewhere is they actually get stuck at the final investment decision point. So to keep it short, that's what I'd like to see, is keep going and try and meet these ambitious targets. And also be quite entrepreneurial. I think India has a chance to really be a leader in this sector now. And I think adopting new technologies as well is what I would recommend to leapfrog ahead.
Thank you. Paddy, if I may ask you the same question, any recommendations to India?
I think, as I said earlier, there is this opportunity to pioneer what we call new oil. New world. Oil is not a bad thing. We all use it. India is a huge user of it at every level, and I think there's an opportunity to be a pioneer in this new space. The only thing I would suggest to government is that it's a huge capital burden to bring out this new technology sector, and so that requires a faith and an investment, and not relying entirely on the private sector. So that's the vision I would sell.
Any specific policy mechanism that you think could help with putting more of the burden on the private sector than the public purse?
I think the way of providing capital more effectively to pretty much all of us on these seats need capital to build out our programs. So how do you support that? Another idea is procurement. So governments, in my experience, are very bad at leading the way in procuring their own energy in a renewable form. And these mechanisms can guarantee a market and really bootstrap everything we're doing on these amongst my colleagues here. So I think government needs to think seriously about how to really make these things happen and not rely on everybody else.
Thank you. Ashwani, your wish list.
So firstly, let me just say that what India is doing is something which actually should be emulated by many other countries. So India has taken a leadership position, and whatever policies India has already implemented, or those are in process, are the right steps to take, and the Indian government has been very consultative about it. They have not taken these policy decisions just on their own. They have invited the industries, comments, and every policy which has come up, including the National Green Hydrogen Mission, has input from the industry. And by the way, this is one area where a lot of Indian companies are not competing with each other, but competing with the blue projects potentially. So all of us sit on the same side when it comes to the policy ask. Now, having said that, it doesn't mean that there's nothing which Indian government should do more. There are certain very minute aspects, like each of these project is $1 billion plus project. Even if we develop it in multiple phases, If we do it all in one shot, it's something like $8 billion per million ton of ammonia, and for hydrogen even more. Now, the cost of funding in India is not that cheap. So what India potentially should be doing is to bring in investment at a lower cost for the developers to be able to produce a competitive product for international market and still maintain the threshold IRR. The other thing which India should be doing is to sign more bilateral treaties with countries to start trading our carbon credits under clause 6.2 of Paris Agreement. Now, India was supposed to achieve the target which it was supposed to achieve in 2030. India achieved it already in 2021. So whatever excess credits which we are generating today are not of any use, but we can trade them with countries where there is a deficit in their obligations, the mitigation commitments which they had made under Paris Agreement. So that's another area which is very important. And last is a very important one. Again, some steps have been taken towards building electrolyzers in India by offering PLI, etc. But it's not just the manufacturing. I think bringing in technology from companies like Ceres and many other new technologies are emerging to come and manufacture in India to develop a skill set as well as use the lower manufacturing cost in this country and then exporting it back is one of the other recommendations.
Thank you very much. Ranjitji, your views.
No, I think Ashwani has covered everything. So I think he's done a very good job in covering this for us.
Thank you very much. Dr. Prasanna, you get the last word.
Okay, so I'm going to summarize in a few thoughts. So our principles, coming back to principles, policy has to be clear, predictable, technology neutral, and market driven. I mean, those are some of the principles that we try to see everywhere we go about policy. Now, there are three areas I think India has a huge potential, absolutely has a huge potential. Building on the Inflation Reduction Act that is written by reduction of carbon intensity, that's the real goal, is you want to reduce emission while supplying the energy, and that's what I mean by technology neutral. So focusing on writing a policy that will encourage all solutions, and written what the ultimate objective is to reduce the carbon intensity on providing those solutions should be there. The second point is both sides of production and demand have to be included in the policy. Some policies are only focusing on the production side, but once you have hydrogen, if there is no demand, it will not go anywhere. The value chain just stops there. So policy has to focus on both production and demand. The third point I would make is infrastructure investments. As I said, infrastructure. Use infrastructure that exists today to the extent you can, and also build new infrastructure to further the value chain. So policy has to enable infrastructure investment. And the last is innovation, research and development. So policy has to really further all solutions. Green hydrogen future is green, but the question is when, and when that cost will come down, and how can technology really help to deliver that cost down. So those are the 4 points on policy, I would say.
Thank you very much, and that's a great summary of recommendations to end this panel on. Please join me in thanking our great panelists, and wish you all a wonderful rest of the conference. Thank you very much.